Hi friends, today we will see how vectors are represented in a coordinate system. So vectors can be represented anywhere in the space without any axis, just a line and an arrow which will define the magnitude and the direction. But in coordinate system, it becomes really easy for us to analyze a given vector system. So we will have some kind of vector coordinates or some kind of coordinates developed for our ease of calculation. The coordinate systems that we will be using is an orthogonal coordinate system. What does it mean? Orthogonality stands for perpendicularity. When I say that two vectors are orthogonal, that means they are perpendicular. When I say two lines are orthogonal, they are also perpendicular. So when I say an coordinate system, I will be developing some coordinate systems which will be orthogonal in nature. Okay, they will always have 90 degrees angle between them. In schools, we have studied a coordinate system which we called as XY coordinate system, in which we have a real line axis called as x-axis. We have a real line number which we called as a y-axis, right? And if you can see that these lines can extend up to where? Minus infinity to plus infinity. Here also minus infinity to plus infinity. So this real line axis can extend up to plus infinity and minus infinity, and here minus infinity to plus infinity. And the point, if we denote your P, is given as, let's say, x comma y, isn't it? What is x comma y? When I say a P point, that is a distance from the origin, here I have a point 0 comma 0 where both x and y are 0. Here it is x and comma y. How does we got this? We know that there are x units I have to walk in the y distance, y units I need to walk on the y axis, and x unit I need to move on the x-axis. So when I'm moving on the x-axis, if I move x units, where I will reach? So if I move x units in x direction, likewise I will reach here. But then it is not over. I need to go up to here. So what I will do? I will move in the y direction in y units. So this is x unit movement, this is y unit movement. But the x unit movement is in x direction and y unit movement in the y direction. So how will I call this? Let's say I have a point P. Let us take a point P over this side. I have a point P which is giving me value as minus 3 comma 10. Okay, the value of point is minus 3 comma 10. How can I say this point? How can I reach up to point 10? Is by joining the line from here. This is 10 and this is, we can say, minus 3, right? So what I'm saying is I will walk how much? I will walk minus 3 units, or let's not give minus 3 units. I walked only 3 units. In which direction? In minus x direction. Very important. How I called it? I walked 3 units, okay? But in which direction? I walked in minus x direction. So the directionality has minus sign. 3 do not have minus sign. 3 is a magnitude. What is having a minus sign? The directionality. I am walking in minus x direction. How many units? 3 units. But where I will reach? If I walk this much, I will reach up to this point. Now I have to go up, isn't it? So I will go up. How many units? So I will go up. Here I will move 10 units. And in which direction? In positive y direction. So I'm moving 10 units in positive y direction. So if I join this, so if I call this as, if I draw one more line over here which is parallel to this line and draw an arrowhead to it, then you can see that I'm actually going from this point to this point is same as that of going from the origin or the center to this point. Okay, so what will be my resultant? Resultant is always this vector plus this vector, as we have seen previously. Now what is this vector? This vector is like this. I can say that the resultant, that is a total movement from the origin, will be 3 units in negative x direction plus 10 units in positive y direction. And we know that every vector can be represented using magnitude and direction. So here we can see that I have 3 in the minus or negative x direction and 10 in the positive y direction. So to represent a vector in an xy coordinate system, what I'm using is, or just to reach from one point to other point, what we are using is, we are saying that there will be a magnitude which we called as 3 units, and there also requirement of a direction. There is a requirement that I will represent 3 units in which direction? So in x direction. And z in which direction? Again in the y direction. So to complete this, we know that we represent vectors, or we represent the vector in terms of, let's say if I have a vector, then we represent a vector with its magnitude and a direction. And for direction I use which vectors? We use unit vectors. So when I represent this structure now, this resultant, I can represent it in this way. I can say that the resultant R is equal to minus 3 ax cap, where ax cap indicates the unit vector, it's a unit vector in x direction. But we don't have x direction, we have negative x direction. So the minus ax cap will denote the negative x direction, plus what we have, 10, okay, a y cap, where a y cap is unit vector in positive y direction. Understood? So one resultant vector R in a coordinate system can be decomposed into 2 components. One is in the x direction, one is in the y direction. This is called as decomposition of a vector in its normal components. So I can represent any vector in normal components, right? So as you can see here, I am using a word called normal components. What does normal means? Perpendicular. Perpendicular means orthogonality. That means this number system or this coordinate system is also perpendicular. How it is perpendicular? The x-axis is perpendicular to the y-axis. So I can resolve a vector into its perpendicular component, or I can say the addition of the components gives me the resultant. Isn't it? Both are one and the same. I started with components and went to resultant. But you can, if you know the resultant, you can divide it into 3 components. So every vector can be resolved or can be represented in its orthogonal components. That becomes simpler in orthogonal number system. So now you have understood that how we are getting these 2 unit vectors and what this resultant is all about. Now suppose I bring into picture x-axis, okay, I have, let's say, I have now three lines which are extending like this. Okay, the first line, which is horizontal, I called it as a y-axis. So this is my y-axis. The line which is extending in and out of paper, I called it as my x-axis. And the line which goes above and below on the paper is called as the z-axis. So how many lines we have drawn? We have drawn three lines. All are perpendicular to each other. What does it mean? If I see x and z, then this is perpendicular like this. Okay, x-axis is perpendicular to z-axis. X-axis is also perpendicular to y-axis. Okay. Now what about z-axis? Yes, z-axis is also perpendicular to y-axis in this way. Right. So all three axes are perpendicular to each other. This system is called as the orthogonal system. But how many lines are there? X, y and z. So this coordinate system, which we normally called as a Cartesian coordinate system, or it is also named as rectangular coordinate system. Okay, and if suppose I wanted to denote a point in this plane or a point in the any given point P can be now represented as x, y, z. So previously, as we have seen in xy coordinate system, we have only x and y. Now we also have x, y and z. So the resultant to this will be, if I draw the resultant like this to the point, this is R, then it can be resolved into again three components. One will be along x, which will go like this. One will be along y, which you will go like this. And the second will be along z, which you will go like this. So this much unit you walked, which is called as x unit. This will be y unit and this will be z unit. So how can I represent the resultant R? The resultant R in the same as that of the previous case. Now there are three perpendicular components. One is in the x direction, one is in the y direction, and third one in the z direction. So in the direction of x, if I wanted to write the R, resultant vector R, then I will write as x unit in x direction plus, I'm purposefully taking all positive axis. There's no need that you will always have a positive axis. You might also have a negative axis. Then you have in the direction of y units in the direction of y plus z unit in the direction of z. So this is my resultant vector will be. So when I represent a point P, which is given as x, y and z, then I can represent the resultant vector from origin to P as x, x cap plus y, y cap plus z, z cap, where x, y and z are the units along x, y and z axis, and ax, ay and az are the directions in the x, y and z and the z respectively. So in general, when they draw a coordinate system, how they will show is, they will draw the coordinate system with, let's say this is my z axis, this is my y axis and this is my x axis, purposefully taking all to be positive. So this is x axis, I'll put a capital letters, y axis and z axis. Then on the three axis, I can show that if I move along this direction, okay, then this is a y cap. If I'm moving in this direction, then this is a z cap, and if I'm moving in this direction, then that becomes a x cap. Okay, so we have a unit vector in which direction? X direction. We have a unit vector in Y direction, and we have a unit vector in Z direction. Okay, so this is a Cartesian coordinate system, or we also called it as a rectangular coordinate system, in which you are allowed to move on rectangles. Now in this coordinate system, we can have something called as a planes, or we called it as a plane surfaces. How will be a plane surface on this coordinate system? So the plane surface will be like this. If I am allowed to move anywhere in the xy direction but not in the z direction, so let's say z is equal to 0 and I am allowed to move only in the xy direction, then the movement will be in somewhere around in this plane. So if I consider this to be my axis, then in somewhere in this plane. So this becomes my xy plane. So here the z value is 0 everywhere. So I can say that this plane which I have just drawn, which can extend in all the directions. Here if I am standing over here, there will be some x and y value. If I stand over here, there will be again some x and y value. But what is the value of z? The z value over here is also 0. The z value over here is also 0. So I can say that the points lying on this plane will have constant value of z, but will have changing value of x and y. Isn't it? So whenever I am saying xy plane, which will be the horizontal plane, and if I move on the xy plane, then z becomes constant. So I can place such kind of planes above. For example, when you see a building, okay, the 0th floor is one xy plane where z is equal to 0. I move on to first floor, then z becomes equals to 1, and I can move anywhere in the xy plane. Z is equal to 2, second floor. Z is equal to 3, third floor. So you can take each floor as a constant z plane. Okay. When I say constant z plane, it is assumed to be xy plane, or it is presumed that it is an xy plane. You are free to choose any value on x and y on that plane, okay, keeping z constant. So it is not mandatory that z should be 0, but z should be constant is mandatory. So you can have z is equal to 10, z is equal to 1, z is equal to 100, whatever it is, but it should be constant. And then that plane will have only points of x and y. That is called as xy plane. The second plane that I can draw is let's say xz plane. I draw an xz plane. So that plane will be exactly standing above. So it will be going, let's say, from here it goes like this, down also it goes like this, okay, and with respect to z axis it goes somewhere like this and somewhere like this. Okay, so the plane that you see over here, this one, this plane that you see over here, which is standing above the sheet, which is likewise, okay, which is standing on the sheet, is nothing but my xz plane. So this is my xz plane, which is standing like this. The plane which is sitting on the bottom or on the sheet of the paper is the xy plane. So this becomes this plane which is marked with red is the xz plane. On xz plane, who will be constant? Y will be constant. For example, you are in a room, you say that this is wall number 1, and then after some distance wall number 2. Isn't it? So there the y-axis has been moved, but on the wall the height of the wall is changing, and likewise you are allowed to move. So on the wall, when you see that it is allowed to move in the x direction and in the z direction, but y should be constant. Once you shift the y to the next wall, again x and z can be varying, but y will remain constant. So this is y constant. These are this is YZ plane. Sorry, this is XY plane. I'll write it again. It is XY plane, okay, with Z constant. Okay, it is YZ XY plane with Z constant, the one which is floating like that. Now the third plane that lies is YZ plane that I wanted to draw. So in YZ plane, X will be constant and Y and X are allowed to move. So when I wanted to draw a YZ plane, okay, so I will take the axis as Y, I will go up, let's say I will draw from here, and then we will go down also the same way, keeping this as my axis reference, and let's say we will go down and draw another plane which will be visible, a quite visible plane. Okay, and then I will take the reference of the x-axis and I will draw it, let's say over here or afar, and with the x-axis, z-axis I will draw over here also. So the curve with the magenta lines are actually the YZ plane. So this is my YZ plane, okay, which is exactly the one which is standing on the page, okay, which is standing on the page facing towards you. So the magenta curve represents the X, this represents the YZ plane, and who is constant over there? X is constant over there. Okay, so with X constant, YZ plane, red plane is XZ plane where Y is constant, and blue plane where XY plane and Z is constant. So in the XY coordinate system, okay, we have the resultant represented as X AX cap plus Y AY cap plus Z AZ cap. Then we have three planes, as we have seen over here, XY, XZ and YZ plane, and three unit vectors AX, AY, AZ. So this is all about a rectangular coordinate system. The point must be denoted with respect to X, Y and Z units. Okay, so which is very similar to our normal school XY coordinate system. Only thing is one more parameter is added, which is Z, which will give me the height. I hope you have understood the first coordinate system, which is nothing but a rectangular coordinate system or a Cartesian coordinate system. Thank you.